Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. Monsieur Kildall, est-ce que je peux avoir $1?
You got me on that one.
What I was asking you was, would you lend me $1? Only I was using the French language to communicate to your brain, your computer, and I guess you're programmed in the English language, so you didn't perform the program the way I hoped you would, and you didn't give me the $1. The point of this little story is that our subject today is computer programming languages, Gary, and of course there are many languages you can program in, just like there are many languages we can speak in. Before we talk about these different individual programming languages, I thought you might explain the different levels of computer language.
Well, there are three major levels of computer programming languages that sort of depend upon your level of sophistication, what you're going to use the language for. The lowest level is what's called machine language, and that's the language the machine understands, the ones and the zeros. The next level up from that is what they call systems languages, and the languages like the programming language C would be in that category. And those languages are used to program applications such as word processors or spreadsheets. And then the third level, the highest level, is what's called an application language or an end-user language. And those languages like Fortran, COBOL, Logo, so forth fit into that category. And so we'll get a chance today to talk about some of those languages and see how they're used.
Okay, indeed. We'll see a demonstration of COBOL, Forth, Logo. We'll talk about Pascal. First, though, let's try to understand a bit better this problem created by having so many different programming languages.
This multilingual keyboard can perform the tasks of interpreter, grammatical advisor, and artist in translating English sounds into Japanese text. The program does for human languages what most computers are incapable of doing with their own languages. Because machine codes vary from one microprocessor to another, the same programming language cannot be shared by two different computers. For example, Apple BASIC is not IBM BASIC. A language customized for one machine will not run on another. Like their human counterparts, computer programming languages differ in structure, syntax, code, and even symbols. But the lack of standard transferable code puts the programmer at a time-consuming disadvantage. After learning to write a program for one computer, he must rewrite it for another. Because of a computer's wide range of applications, languages are specialized. Fortran for science and math, COBOL for business, Logo for education. The more friendly a high-level language, the more translation it requires before it can be executed at the machine level, and correspondingly, the slower it runs. In some cases, lack of speed at the machine level is a trade-off for quick interaction with the user. Adding a third layer of complexity to computer programming is the assembly language, required to translate high-level languages into machine code. Programs written in assembly language are faster in execution, but more difficult to write than those in a high-level language. Software firms are developing more powerful, portable languages for use in micros, but as long as computer manufacturers design exclusivity into their products and languages, users are faced with the same dilemma. Machines that will communicate with everyone except each other.
Ruski Yazik.
Our guests today are Paul O'Grady. Paul is Executive Vice President for Strategic Development at Microfocus, and Paul works with COBOL. And next to Paul, Dave Eisenberg, a Senior Engineer and Software Developer with Apple Computers, and Dave works with Pascal. Gary.
You know, Stuart, there have been a lot of languages around for several years that are sort of considered traditional languages, like PL1, Fortran, COBOL is a good example of that. And one of the difficulties in the small computer industry is trying to bring those down into really usable languages. Nowadays, people expect a lot more interaction in the way they deal with computer systems, and I know that Microfocus has been working on COBOL, trying to make that more of a personal orientation. So what have you done?
Well, we see ourselves, Gary, as in the business of exploding myths about COBOL. The mainframe people have myths about it, that it can't run on this kind of equipment. And the microcomputer people have myths about it in the sense that they just don't like the language at all, a lot of people. What we try to do is we try to differentiate between the environment and the language itself. And the environment in the past for COBOL has been the mainframe environment. We believe that that is what has led to much dissatisfaction in that environment. What we've done here, though, with Personal COBOL, which is one of our latest products, is show what we believe is the kind of thing that can be done and which is very appealing on this kind of equipment. I've already put us into Personal COBOL. Personal COBOL is a combination of an editor, a forms generator, a checker, syntax checker, and the ability to run programs. In this case, I'm going to go straight into the forms part, and I've already created a form for us.
Now, this is a form that you created by drawing the lines in and so forth.
Yes.
To begin with.
Everything that you see on this screen here was created by directly keying in the lines, the text, the X's, the square brackets, the whole thing. And I did it in approximately 5 minutes or so before the program started. What I'm going to do now is to start to generate the COBOL for this, because another of the businesses that Micro Focus sees itself as being in is trying to redefine the term programming. And programming for us is simply generating code in whatever way possible, the most effective way possible. In this case, we're going to generate all of the code for this screen automatically. That I'll do now. We also wrote this program so that people who have finger trouble like me never really crash the program. I hope to prove that. I'm going to create a complete program, an index program. I position the cursor as it tells me to, and we're now generating COBOL in the lower part of the screen.
Now, this traditionally, again, if you talk about traditional COBOL programming, you'd start with a program that would you'd work out all the details of it that would produce this screen. Is that
Yes.
correct? Now, in this case, what you've done is you've manually made the screen up by moving the cursor around, and it's doing the inverse. It's actually producing the program instead.
That is
right?
correct, yes, and we've already produced it. We've produced the COBOL for that. What I can now do is I can decide whether or not I want to save that. In this case, I'll exit without saving. I've already created the text elsewhere. As I said, some people have finger trouble, and I always have finger trouble at points like this.
Paul, you mentioned that some programmers have not liked COBOL in the past. Why is that? What is it about it that created a problem?
There is a lot of detail to the syntax. The period at the end of each COBOL statement often causes problems, but there is also the need to define records at the beginning of a program prior to getting into the guts of it, making the program do the work. However, that comes from the type of application that COBOL was designed to bear upon. Those are typically data handling applications, file manipulating applications, and for that kind of application it is necessary to create the records to start with.
And in fact, what you worked with here, though, is again a program generation concept. Now, if you talk about forms, you put up forms ahead of time and then you generate a COBOL program. Can you also do that for data structures for accessing files, or is this something that would come up in the future?
In terms of the data structures, they're already built into the index sequential file mechanism of the COBOL, and we adhere to the COBOL standard. But yes, in the future one can conceive of the ability to input the data structure directly into the program prior to generating it.
Dave, you work primarily with Pascal, and tell us about Pascal and why you like it. What are its special features?
One of the nicer things about Pascal is its power of expression in terms of, for a small amount of text on the screen, which is, given the right programmer, awfully readable, you can get a lot of power out of it. It allows you to express an algorithm, a method for doing a computation or some process, the way you think about it instead of having to force it into some other mold. And that's one of the advantages of COBOL for business applications. It was it's built for that, such that you can think in terms of a business or record problem and do it that way. Pascal is similar, but pretty much for more general purpose applications.
Pascal had several years ago a lot of interest in terms of using it as a systems language, and it was sort of touted as the all-purpose language for doing everything. What happened? Why did that not really take place?
Pascal was first designed as a language for teaching about computing and computer science, and even its inventor admitted, Nicholas Wirth, admitted that that was what it was for. And he's been at work lately on something called Modula, which is designed to take over from Pascal in terms of the systems area, which lets you get closer to the machine level, but still again have the power of expression that Pascal has.
Paul, in coming up with something like personal COBOL, COBOL we think of as you say, a mainframe, big corporation environment type language, what kind of use, what kind of application do you see with something like personal COBOL?
Well, we see not just the classic business data processing applications, we see personal applications such as diary application, personal filing applications, and we also see office automation applications all being applicable to COBOL. They all require data handling and file maintenance, which COBOL was originally designed for.
I think it's also important to think of COBOL as being a system implementer's language. That is, it's not the kind of a language that you really promote as, say, an end-user language. Is that correct?
I would agree with that, certainly.
More to the kind of an individual who is going to go out and write some extensive programs and then go off and sell those programs. And so there's a whole layer of programming languages that fit in that category that maybe an end-user might not even want to consider, at least until they've had some experience with programming languages.
Yes, I agree. I think none of the standard, the normally accepted programming languages are applicable for end users at this point, personally. Not even BASIC.
Okay, well, our third guest is going to talk to us about Forth, and that's coming up in just a moment. Joining us now is Elizabeth Rather. Elizabeth is president of Forth Incorporated of Hermosa Beach, California. Elizabeth, tell us about Forth. What makes that a unique programming language?
It's unique in two respects. First, it is the only language that I'm aware of that was designed from first principles to run in a small computer, doing interactive software development for real-time applications. The second area that it's unique relates to Gary's remark early in the program when he mentioned the three levels of programming, and Forth incorporates all of them. You can work right down at the machine code level when you need to. You can do system programming in Forth. In fact, the operating system that we're running on here was all written in Forth. And you can do very high-level kinds of things, very high-level application-oriented programming. For example, we have here a graphics program that is loaded, and I have a list of a large number of demo programs that I could run here. I'm going to try one of them called Logos, which draws, it's not related to the language logo, it draws our company's logo, which is a little bit chauvinistic, but the principal thing that this is illustrating, this is a rather complex figure here, and we're doing area fill, which is a fairly sophisticated graphics technique, and it's doing it very fast and very well. And it's now got everything all white except for what was concealed in the little spots there, and eventually we'll be able to make even the little spots go away. But there are high-level words that put together this entire process, and I can show you some of them. I can say,
was that entirely done in Forth? As far as was it any assembly language involved in that area fill, or was that entirely done in Forth?
No, there is some assembly language.
So it's a mixture of those two.
Yes,
in Forth.
and you put in as much assembly language as you need, either to control the hardware directly or to make things run fast. And you notice this is a very fast program. But you have the high-level version. I can say locate logos, locate fill, for example. This is the area fill routine, which is written in code, because area fill is something that needs to run very, very fast. So you have assembly language code here, and then we have some other words called dark and light
So
that
part of
are
this
what
is
we call
assembly
high
language.
level.
Part of this is assembly language you're showing us. Part of this is fourth, in a fourth statement. Is that true?
Yes, that's right. The word dark, for example, that I'm highlighting here, makes the screen go dark, like that. And it simply picks up the color and blackens the screen and then resets what the previous color was so that when you draw something again, you'll draw it in whatever color it was. And
So what
you
we're
can-
seeing
you
right
can
here
work
with the
very
highlighted,
high-level things.
the highlighted line itself is fourth in this case.
Yes, that's right.
Gary, you have, your company, Digital Research, has Logo out
I
now.
just happen to have a disc with me.
And maybe you could load up Logo for a minute and show us how
Elizabeth's going to
Logo
give me some help over there with it.
compares to these other languages. Dave, while we're waiting for Logo to boot up there, let me ask you, are there always going to be all these different languages, or are they going to merge into a smaller number?
Well, it would be nice to have an ideal language, but I don't think it'll ever really happen. Mostly because, well, for example, COBOL, which we saw earlier, is designed and used primarily for business applications. Forth is designed for real-time applications. Logo is designed for education, teaching people to program. And, well, when you discuss languages, it almost becomes a religious argument. But really, a language is just a tool, and it's like arguing, well, which is better, a hammer or a screwdriver? And you tell me what you want to do with it, and then I'll tell you which one's better.
I think that's probably the most important point about languages, is that it's, if you use the right one for the right application, then it's the most effective thing you can do. Logo is like a lot of different interpreted languages. It gives you an immediate feedback to the work that you're doing. And what I'll do here, I'm just going to make this screen into a split screen. And I'll show you what I mean by the immediate interaction. For example, if I type forward 30, then you see the pointer, or the turtle as it's called, moved in a direction. Now that's immediate feedback to what you typed in. Now a lot of programming languages like Fortran, or let's say many Pascal versions, are what they call compiled languages, and you don't get immediate feedback. You have to go through an edit step and a compile step and maybe even linkage editing, and that requires a lot of abstraction, a lot of thinking about what you're doing. Where languages that are interactive, like Logo and Forth and other interpreters, give you immediate feedback. Now this next thing I'm going to load in here is called Blackjack, and it happens to be a demo program. You're familiar with that one? Okay. Now the reason I'm loading this one, this happens to be an example of how you use turtle graphics or graphics to draw pictures. And this particular program was written by a 13-year-old in about 3 or 4 days. Now, it was a rather precocious 13-year-old.
It's your son. That's
well,
not
no, actually,
he's genetically superior, Gary.
It was actually his friend.
Okay.
but the point of it is that you can do things like this, like a little game of blackjack, without a great deal of effort in a language that's interactive and graphical in nature.
One of the nice things about these languages where you define your own words is that you can make it read fairly close to English. You can actually pick up a program and read it.
Gary, while you're playing blackjack there, most new computer users get exposed to BASIC as their kind of language, and we haven't really talked about that yet. You're showing how easy it is to do a game like this in Logo. How is it better than BASIC? What are the problems in BASIC as a programming
Well,
language?
BASIC is historically came from Fortran, and has a lot of the original problems of Fortran. Fortran is one of the, in fact, may have been the very first, I guess, high-level programming language, recognized high-level programming language. And so BASIC sort of followed that genealogy, and has a scientific orientation to it, step-by-step breakdown of the problem into simple steps that sometimes not really the best way to think about the breaking a problem apart. Now, Logo came from the MIT Learning Project, where they thought about the problem solving itself, and then the language that would be an underlying language that would be good for that. So I think BASIC is just it's an easy language to learn, but it has its limitations as soon as you start to do anything complicated.
BASIC was designed to be learned quickly by college undergraduates doing very simple things. It wasn't designed to do either sophisticated programs, nor was it designed to grow. And I think both Forth and Logo have the capacity to grow in the sense that you can teach them new things, and there is a learning process going on in the computer, or between the programmer and the computer, which is very similar to the learning process of teaching a small child to do new things.
Well, I think that's interesting with Logo also is that it's sort of a bait and switch tactic in the sense that you sort of get children interested in the language because of the graphics, because they think of it as a big track that they program and runs around the floor, in this case a turtle. But behind it is a language, Lisp, which was used, it has been used for years in artificial intelligence, and all the Lisp processing and that's a part of Lisp is also part of Logo. And so there's the Forth and Lisp share some foundations that are somewhat similar.
Dave, are there any new languages on the horizon, or do we have a finite number now?
The last roster of programming languages that I saw had about 700 or 800 names in it, and I don't see an end in sight. A lot of languages are designed for one specific thing. I guess you'd call them almost a toy language, except to the person who invents it. So most of them, I think, are offshoots of the main languages like Fortran, COBOL, ALGOL, or Lisp. And yeah, as long as people have ideas for things they want to do, they'll invent a new language.
So it's a kind of evolutionary process, I think all of you said, where one language kind of builds on.
Well, I think also it's a matter of getting started as far as learning a language. Once you've learned one language, it's not very difficult to start picking up other languages, but it seems to be a threshold to get over the very first time. So I think that's an interesting thing about learning languages, that you get started at least.
Okay, well, we started and we're finished. Thank you very much for being with us, and thank you for joining us in this edition of the Computer Chronicles.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.